All right, this talk is going to start with me embarrassing myself a lot. So I'm glad I got that out of the way. I know it's really early. 9 a.m. is just a touch too early. I get paid a lot of money to be an engineer, and I don't wake up this early for that. So we're all happy to be here, I guess. First thing I want to do, I want to wake everybody up. I know that, again, it is 9 a.m. The coffee is still coming in. So I'm going to do this. It's not a lot of claps. It's just going to be one clap. So we're going to all come together and just do one clap together, all right? For the people, there's people like behind the pillar. That you ready for this clap? OK, David, you're ready for this clap. All right, ready? Great, thank you. So you might be wondering, why is this off-brand Randall Park giving a talk at GraphQL Summit? And first off, how dare you? How dare you? Because you're absolutely correct. I am dressed up as Randall Park from Always Be My Maybe. And side note, this movie is incredible, okay? I love this movie. Another embarrassing fact, I guess, why is it embarrassing? I was crying at the end of this movie. It is great. It was a great, incredible movie. You should go watch it. You all have Netflix subscriptions, we know, okay? And if you're not from the US, I've seen your Netflix accounts. You have access to everything. So you have no complaints, okay? So go watch this movie. It's really solid. But this oversized blazer is oversized and a little itchy. So I'm going to take it off here. Great. Hello. My name is not actually Randall Park. My name is John. I work as a staff software engineer at Coursera on the developer experience team. And on that team, we spend a lot of time building out the tools, workflows, processes that our engineers use on a day-to-day basis. That includes GraphQL, and most recently, we're taking our 3-year-old GraphQL server and saying, hey, could we do this better? And the answer is yes. So that's what we work on day to day. If you haven't heard about Coursera, we envision a world where anyone, everywhere, anyone, anywhere, I can read the things, can transform their life by accessing the world's best education. We have lots of great university courses on there, even degrees. If you want to get a master's in CS, if that's your thing, you can get it on Coursera. So check it out if you have an opportunity to do so. I also am a host of something called GraphQL Ramen. It's a small little meetup thingy where we just go and grab ramen together and talk about GraphQL. I've ran it here in SF a few times, as well as in Toronto and New York. So if you want to get in on this, if you love ramen or you love GraphQL or you love both, go ahead and follow me on Twitter, and you'll check out the next one, which might actually be in South Bay. I promise. Christina, I promise. South Bay. OK. So I also, the title of this talk actually should have been GraphQL servers in almost every language. We only have half an hour, so I don't really have enough time to go into literally every language. But really what I want to talk about is all the servers that don't get any of the glamour, any of the hype, who might not show up in a presentation. We, as GraphQL enthusiasts, might see a lot of JavaScript through today and yesterday. But there's a lot of great servers out there that have a ton of great features. So I'm going to be going through and exploring all those servers and really showing off what are the features, what are the things that you want and should ask for from your server. So it's important to note that we want to break down what actually is a GraphQL server. Because we want to kind of figure out what are the constituent parts that you could make decisions about, right? What are the things that can change between different languages or different implementations? So realistically, it comes down to schemas and resolvers. And there's some decisions around how you get to both of those things. So you have two big questions that you might answer when you are trying to figure out whether or not this server implementation is good for you. The first is, how do you generate the schema? And the second is, how do you take that schema and then ultimately resolve it against the underlying data? I'm actually going to skip over most of the caching and databases and all that sort of stuff. It's really just getting the schema to that next layer, which is the set of resolvers. So first off, generating a GraphQL schema. There's two major ways to do this. You could do a combination of both, but it just might be hard to process in your head. But ultimately, what you want to figure out is, what is your source of truth? What is the thing that you refer to that when you edit your schema, you're going to edit that thing? The first might be SDL first. So SDL is the GraphQL schema definition language. And you've probably seen tons of examples of this. It's fairly easily readable. You have a nullability with the exclamation mark. You have arrays with the array the square brackets, all that sort of stuff. There's a lot of languages and servers out there where you start with just writing schema definition language, and that gets translated into something else for that particular language. The other decision that you can make is code first. And code first says, OK, I'm writing in JavaScript, or I'm writing in TypeScript, or Python, or whatever it is, and I just want to write Python. I just want to write TypeScript. I don't want to write GraphQL SDL. And this example is Nexus, which is a TypeScript server where you write everything out in TypeScript. Object types, nullability, strings, like all the fields and stuff like that show up in TypeScript, and then that gets translated into GraphQL schema definition language somewhere down the road, if that is something that you choose to have. The second thing, how do you connect the schema to the underlying data? How do you actually get the resolvers to work together? OK, so this is from the GraphQL specification itself. It's kind of very verbose here, so I'm actually not going to go over this. Actually, the GraphQL spec is really fun to read through. So if you have a chance, you should read through it, and you'll find out cool things like the commas actually don't mean anything. They're just white spaces. So you can just throw tons of it. Just put tons of commas in there, right? Just put like 20 of them. Doesn't matter. So anyway, this is what they're talking about when we say resolvers. It's essentially how do you get the value for a particular field. And concretely, and I'm going to use a lot of examples here from Coursera. We have courses, and then you have partners, and partners are the universities or the enterprises that are giving these courses. This is a very easy resolver, where essentially course.partners is just you say, I've been given a course, so just say return the partners thing. So what is the value for this particular field? Great. Now that we all know how to build GraphQL servers, we're going to actually go beyond what's actually specified here, right? So what I showed you just there was the concrete, OK, here's what's in the specification for what a server must provide. But of course, we want more features than that. We don't want just resolvers. Otherwise, we could build that with any language. What we really want to figure out is what are the things that make it really great to build GraphQL in this particular language, in this particular library. So in practice, we're going to go through a bunch of these servers. And of course, again, it is 9 a.m., so I'm going to have to ask for a little bit of audience participation. I know everyone here is really excited about this. And so in this next phase, I'm going to have pictures. And with the pictures, if you know what language or what library I'm talking about, feel free to yell it out. And I know that some people are very averse to yelling at speakers, and you definitely shouldn't. But I will give you permission for the next 30 minutes, for the next 20 minutes, to shout at me only when the images are on the screen. Okay? And these will be easy. I'm not like they're not going to be very abstract. You'll get them. So if you feel inclined, just shout it out. Okay? Great. First one. Oh, I heard it. What was it? Louder. Juniper. Great. So Rust. Rust is a language. It is a language. And one of the GraphQL servers that is implemented in that language is Juniper. And this is it's a really, really solid. They have great docs. I'm reading through all those docs. I know nothing about Rust. And they're going through, and I can understand everything. So the way that it works in Juniper is that they do code first. They have these concept of structs, kind of like they're like types or objects in Rust. And they use something called attributes. And those attributes are these little hashtag, like Octothorpe, whatever you call it, array thing, derive Juniper GraphQL object. It takes that struct, and it goes ahead and translates that into GraphQL SDL. Now, what's interesting about this is that in Rust, it's somewhat more difficult than normal to make optional types. So instead of having everything nullable by default, everything is non-null by default. And I was still digging a little bit to figure out if this was because it was hard to type. But if you look at that bottom one here, this option string, that's how you would define a nullable string. So the sort of nature of the language itself is informing the decisions that they're making in the server and the process there. So I thought this was really, really cool. Definitely worth checking out if you're into Rust, and even just reading the docs, because docs are really, really important, and I really enjoyed reading through these ones. All right. Any guesses? Green Fairy. Absinthe and Elixir. So the language is Elixir. The library is called Absinthe. And also, I'd like to say that I love all the names for all these GraphQL servers. They're really, really fun. You're going to get some really fringe ones. So I hope that this is just the tip of the iceberg. So in Elixir, equivalently, they have a code-first solution here, where they're defining objects in Elixir, and they have like non-null, list of non-null, that sort of stuff. It was pretty good. I actually got this up and running on my laptop too, really, really quickly. So definitely worth checking out. One feature that I thought was really cool about this was something called document adapters. And what they were doing here is that because everything is built code first in Elixir, I think conventionally you don't always use your like camel casing that you might use in a GraphQL schema definition. So instead of having to say, OK, I'm going to use this weird casing in my Elixir GraphQL server, and then so that it translates well to the client, they just translate the two. So you can use your own conventional casing. You can use underscore casing or Pascal casing or whatever it is in Elixir itself. And when it gets translated to the GraphQL SDL, they'll go ahead and camel case it for you. So everyone kind of gets the best of both worlds. You don't need to have to compromise on what kind of casing you like in your server. So I thought this was a really cool feature, and definitely a feature that makes a lot of sense for other languages too. Why is this specific to Elixir? All right. Anything? Java. All right. So GraphQL Java I found to be one of the most highly used GraphQL servers, and they have a lot of really cool names for concepts, including this data fetcher. And I really found that one of the things that was really interesting about one of their features here was something called field selection lookahead. And what's field selection? I'm just going to scroll down just a little bit here. And what field selection lookahead is that they can, in their resolver, or in their data fetcher in this case, they can actually take a look at the query that got made. So they're not just resolving their current field. They can also look ahead and say, hey, you asked for the course. Are you also asking for partners? And if you are, let's go ahead and get that now, instead of waiting to get to that resolver to do that. So I thought that was interesting too, because you can optimize a lot of your queries to say, hey, you're always going to get this thing. You might as well get it now. Or if it doesn't include it, let's just not get this at all. So I thought the data fetchers concept was pretty solid in GraphQL Java. They also have support for defer. And this is something that we've seen in presentations and announcements and GraphQL space many times. But what has been lacking has been actual server support for this. For those of you who don't know what defer is a directive that allows you to say, hey, this section of the query might take a little longer than normal. So let's go ahead and wait for it. Or not wait for it. Let's return the rest of it, and we'll wait. Something else will push this to the client later. This becomes really powerful because now your client can, declaratively say, I want courses and partners. But if there's just too many partners, we'll get the course back with all the other information that we need. And then when partners is ready, it'll go ahead and push it to the client. So GraphQL Java has support for the defer directive out of the box. And that's really, really a solid developer experience to be able to just add that when you have some slow fields, or fields that just you don't need on the first render, right? You don't need all of the data at once. You just need it at some point. All right, there is no way that anyone is going to know what this is. Someone said it. Tartuffe. How do you know that? Is that like it's like a childhood dish or something? Because I had to look at this. I was like, this looks like potatoes au gratin or something like that. Anyway, this is Tartuffe. This is a library from Python. I wasn't kidding. I told you this was a fringe one, and I'm glad that somebody got it. But this one is really, really difficult. Tartuffe is a Python GraphQL library. They do SDL first, and they have these essentially these decorators. And these decorators allow you to resolve certain fields on certain types, in this case, course.partners, and you can say resolve course partners, and you have your typical GraphQL resolver syntax. One of the features that they have, and this comes up in different ways in different servers, so we'll definitely hear more about this later, is this concept of dynamic introspection. Now, what does that actually mean? There's other names for this. Schema visibility is another one of these. But what it allows you to do is that it allows you to adjust the introspection result from your GraphQL schema based on anything. In this case, it might be useful for a role. So say that you are a super user. You can see everything in your domain. But if you're not a super user, maybe you should only be limited to a small subsection of the schema. So in Tartuflat, you can define essentially these dynamic introspection rules that allow you to dynamically determine should this person see the introspection query. So you can give them the GraphQL playground or GraphQL or whatever it is, and because they don't have the right headers or they don't have the right authorization, they won't only see a subsection of that schema. More on this later. This is definitely a really interesting feature and something that comes up in a lot of other servers as well. All right. Guesses? Sangria. One of Coursera's beloved GraphQL servers. We've been using it in production for about 3 years now. Sangria is the GraphQL server that's written in Scala. And while they do have a few different ways, and I also want to make sure that there's a good caveat here, is that most of these servers actually support both SDL first and code first, but there tends to be a focus on one or the other depending on the language. In this case, Sangria does have support for both code first and SDL first, but typically most folks use it code first. And what they'll do is they'll use, in Scala, you have these things called case classes, and they're like objects, I think. And so they can take that object and they can derive it into a particular type. So they'll take that and say, OK, there's a course with ID, string, and all that sort of stuff. Sangria is one of the most feature-rich GraphQL servers out there. It's used by a bunch of big companies as well. And we make judicious use of all of the features. One of the ones that I really love is this concept of query complexity. And what this is the ability to estimate the cost of a particular query before you even run it, right? So under the hood, of course, you have, we have a ton of these slides that are like the n+1 problem. You have like, oh, this thing, course, there could be so many of these, and for each course, you're going to ask for all these partners, and if you don't, query them correctly, you're going to have like, n to the n or n, something like that. And what we can do here is that we can actually attach numbers to these particular requests. So we could basically say, based on a query, what's the number of how complex this is going to be? Let's see if this next one has an example here. So essentially, we can take something like this query on the left here that says, I know it's really small, it says courses, partners, and names, and we can attach a number to it. And when that number comes up, we can guard against that number, and we can say, hey, your query complexity is 100,000. You probably shouldn't do this. Why don't you go ahead and add a limit to that pagination? Because guess what? We have 3,000 courses. You don't need all of them. So if you add that limit 25, we'll say, OK, great. We'll take the limit and we'll say, OK, that's now your number. Now your query complexity is 30, right? Because you make 25 calls, and then, I don't know, maybe each of those calls one partner or something like that, on the order of one partner. So this is a really good way of estimating the cost of a query and allows you to just nip rogue queries before they even start executing. So they'll catch it right before. They'll catch it at parse time instead of at runtime. Another thing that they have is this idea of limiting query depth. Typically, because of this, we are building graphs, there are always cycles. And in those cycles, you could theoretically just go on and on and on and on and on and on. And so we could say, hey, 10 times is too many. Let's not do this. You're doing something wrong, something like that. And again, this is another great sort of compile time guard to, at parse time, be able to say, hey, this is you don't want this. It's going to break everything, or it's going to be really slow. And then back to the other feature that we heard before about selection set look ahead. They have something similar called query reducers that allow you to basically go through the entire schema and the query and figure out what sort of information we're going to need. So in this case, if something needs a username or something needs your authorization and your user profile, it will go ahead and say, hey, we've collected these tags, these concept of tags, and say there is one tag that says you need some permission, and we're going to go ahead and retrieve that. But if that tag doesn't exist in the query, we're just not going to retrieve that at all. So other nice things that help make it easy to run a good GraphQL server. All right. What do you think?
Hot chocolate.
Hot chocolate. Great. C#. So C#, hot chocolate. Really, really interesting name. I actually don't know why. I didn't look into the sort of why people chose these names. I was just happy that all these names were drinks and things like that. So they have a lot of, in C#, they have a lot of great features here. I think the one that was the most interesting one to me was something called export. And on its head, I was like, I didn't really understand what was going on here. Essentially, what they're capable of doing is that they're capable of batching queries and using the results of the first query as input to the second query. And you might be thinking, hey, if I have one big GraphQL query, how am I supposed to resolve the first part of the query and send it to the second piece? And I was also equally confused, and I said, this doesn't make sense at all. So I did a little bit more research, and I realized that this is actually really powerful. The thing that's important to note here is, one, is that that bottom query is technically not syntactically correct because it's missing that variables, the IDs variable. But the query engine is going to go ahead and rewrite that for you. So what it's doing here is that instead of sending one giant query, where maybe in that giant query you have one slow field, what you can do here is you can actually split it up into two separate queries. And what's going to happen is that when you send this request to the hot chocolate server, the first request here to the course catalog is going to go ahead and execute. And when it returns, it's going to take that set of IDs and use it as an argument for the second query. But in the meantime, it's returning the first one to the client. So the client can actually respond to the first query because it's streaming the responses back from the server while the second one is executing in the background. So your client can be doing things, and that second one gets executed and then comes back and does the thing. So it's very similar to that defer directive, where it's deferring the execution of some things because they're not that necessary. But I thought this was really cool because now you can parameterize that defer with different pieces of your query. This is actually really useful for mutations as well, because you can mutate something and then take that result back and use that as the input to another mutation down the line. So I thought that was really cool and a really cool feature of hot chocolate. Guesses? Meerkat. Wrong. It's Go. So that was a gopher. Have you seen a gopher before? This is a gopher. I don't know if it's a gopher. It might be a meerkat. I really don't know. I Googled gopher, and this is what came up. So maybe it is a meerkat. Anyway, sorry, I didn't mean to like shut you down there. It was still wrong, but you know. In Go we have GraphQL Gen. They have a couple of different entry points here, and you know, this is their Go. They have some types, and this is how the resolvers attach to those types. One of the things they have that I thought was really cool is automatic persistent queries. Apollo Server has this support as well, but what it does here is that instead of having to like work out the machinery of compiling queries and things like that and finding hashes and things like that, what it does is that it actually sends the hash of the query the first time, and if the server has it, great. It'll resolve that query for you, and it'll return back the result that you expect. But if the cache doesn't have the query, or the server doesn't have it, it'll go back to the client and say, hey, this hash doesn't mean anything to me. Then the client will go ahead and send it back with the entire query, thus hashing it and persisting it for subsequent queries. So I thought this was a really cool way of automating this process that might otherwise be a little arduous. Ruby, this one was a gimme. Sorry, I think that was probably the easiest one. Ruby has their code-first solution where they have the fields in their Ruby objects. And they have some other good features too. They have something called backtrace annotations. If you're using something like Apollo, you might see errors and you might see the stack trace, but it's hard to see that in your actual stack traces on your servers and your logs. They have a way of parsing that, so instead of just seeing this mess of fields and resolvers, it actually shows you at the bottom what the GraphQL execution path was. So you can kind of see, oh yeah, this is broken because course.partners and then like query.course, and it'll figure out, so it's really easy to parse where exactly in my GraphQL code this is, not just exactly where my Ruby code this failed. This also has field visibility, and again, this is something that was in GraphQL Java. This is an incredible feature because this allows you to, again, shape what your schema looks like to different consumers without having to operationally separate the schemas into different places. And so you can both limit the visibility of the schema as well as the execution and access to those resolvers, and that gives you a lot of power in being able to serve different roles without having to have different servers. And the thing is, I talked a lot about the individual features of nice features for these particular languages, but really, these servers have a lot in common too. And so I kind of, if we think about some of the hard problems, n+1, we talked about this before. Most of the servers use data loader. In fact, they use it verbatim in their language. Elixir just uses data loader. And I think it's really cool. Other things that I think are interesting too are things like custom scalars. So a lot of them have definitions for scalars that they use in their language. For example, URLs, datetimes, UUIDs. These are common constructs that are easy for the servers to support, and they just support them out of the box. And on top of that, you have a lot of middleware, authorization, telemetry, even portability, things like modules. As well as error handling. A lot of the new servers, especially, and a lot of these great servers, have great error handling solutions and make use of things that are not even in the latest specification publication. They're using some of the stuff from the working group error handling specification and exposing that to you. So you're getting the latest and greatest in a lot of these servers already. And on top of that, when you have the concept of modularizing your schema, some packages like GraphQL modules in JavaScript allow you to package up subsections of your schema. But when you have code-first solutions to these servers, you can just use the module system that comes with the language itself. So this is Elixir, I think, that's allowing you to use modules the way that you would use them in Elixir to build your GraphQL server itself. So many servers are out there. They all kind of go beyond the GraphQL specification. And the question that I have for you is, what if all the servers had these capabilities? What if I was just talking generically about, here are cool server features? Why are these specific to different languages? That's the question I have. OK, thank you.